Yes. We were talking about the standard terminology, like what is a model. In machine learning, generalization usually refers to the ability of an algorithm to be effective across a range of inputs and applications. Generalization, maybe if I'm making use of a kind of the algorithm with certain set of the data, and I want to use this particular model throughout my applications with a different set of the inputs. Suppose that we are designing a machine learning model. How is a model said to be a good machine learning model? How can I say my model is good? Because so far, though we have seen some metrics or some sort of the other considerations, but most importantly, friends, there should be a solid measure or metric to consider uh, whether our model is performing really well or not. By checking if it generalizes any new input data from the problem domain in a proper way. See, the point here is when can I say a particular model is good is nothing but whatever the input I am giving in a proper way. If your model is trying to understand that particular input and giving the accurate results or predictions, then I can say that is a best model. So you have trained your model in such a way that, and your training also and your testing also come through with the perfect results. So this generalization helps us to make predictions in the future data that the model has never seen. This is most important thing. And moreover, guys, if you want to say your model is neither underfit or overfit, then only we can say that is a good model. Okay, I have not yet revealed what exactly overfit, and we have seen some uh, sample observation related to the overfitting. But let me give you this example. Uh, just I'm taking the student example, guys. So it is a scenario, okay, where this particular scenario is used to understand the concept of overfit and as well as the underfit. Consider a math class containing three students and a professor. Is an instructor who is giving some ideas and as well as the mentoring or training to the members. Now in a classroom, we can broadly divide the students into three categories. Category A, category B and category C. So the scenario is simple. There is a maths class and where these members were instructed to perform something. Now there are certain members, guys. Okay, so let us understand each category. Okay, so just the first category member. Okay, there are certain characteristics. Student A resembles a student who does not like math because first always we should start with the negative understanding. Negative understanding in the sense even understanding of the data also which is not contributing to our model, which is not contributing to our analysis. So a student, if we are considering, just is not interested in math because she feel maths is very tough. She is not interested in which in what is being taught in the class and therefore doesn't pay much attention to the professor and the content he is teaching. So straight away, this lady, so she's having always chatting and not interested in the class, doesn't pay much attention to the professor. Just like that, she has joined, and of course, her interest levels are not revolving around the session. That is the first thing. And second guy is there where student B. Okay, this particular guy is something like is having another set of the characteristics, though they are friends. He is most competitive student who focus on memorizing each and every question being taught in class instead of focusing on the key concept. It's a by-hearting kind of thing. Uh, like whatever the professor delivers, just the same thing without any mistake, without any deviation, he as it easily reproduces. Okay, and moreover, instead of focusing on the key concepts, he is dependent, guys. B is dependent on the professor. Okay, and now basically He is not interested in learning the problem solving approach. Um, Member A is not at all paying attention, but member B is, of course, he's following the lecture and he's doing all the problems in a better way. But he is not interested in learning the problem solving approach. Problem solving in the sense, if I'm teaching three problems and you have to do the fourth problem yourself. That is what you call the problem solving approach. Whatever the learning happened based on that. Okay, guys, training is different, learning is different, definitely. This guy only following the training approach. Okay, stick to the professor information, and he is not at all interested to acquire more knowledge. He is happy with the notes and whatever the discussions happened in the classroom. He follows strictly the training, and his hobby is to be best in the class and mucks up everything professor says, just reproducing. Just he is not adding any flavor to that. Only as it is he is copying the data and all. Too much attention to the classwork. So just is having classwork, and some people maybe due to the client calls, maybe here and there absent, but still they go back to the recordings and all. Some people even present in the class, but still go back and verify. So take notes and going beyond the appropriate training. Okay, both are appreciated things only, guys. But here, this guy, hobby is to be best in the class so that he strictly follows the instructions given by the professor and whatever the professor gives. So just he's making use of that thing and too much attention to the classwork. His main focus area is attending the sessions and reproducing the activities. One more category is there, the third category student. So if you are considering this kind of students, okay, this kind of the category. Now let us see. Finally, we have the ideal student C. She is purely interested in the learning, the key concept, and along with that key concept, problem solving. So training and as well as learning. Okay, so training is distinct, guys, and learning is distinct. When I was attended with Google on the day of Women's Day, guys, last year it seems, and Google L&D manager is there actually. So she is very competitive and she's a doctorate. And she said one important point, guys, like, though we are knowing, but good things are like that only. No? So training and learning we see separately. In Google, we see separately because there is always research going on. And because Google is having heavy data and we are going to get that particular data in a meaningful formats. And now you see most members searched this particular word in the Google last year. Like that, they release some sort of these things, and you should not Google some of the words. So because this particular Google now become a kind of norm everywhere, and if I'm having any doubt related to my publication or related to my research, or maybe if I want to get some kind of the best practices, or in all the ways. So this particular student C, she is of course attentive in the training, okay, and problem solving approach. And based on top of the discussion, whatever, so just she's paying attention to solve or to go into the advancements also. Approach in the maths class rather than just memorizing the solutions presented. So memorization is of course for the unfortunately, guys, for the certification and all, you have to memorize a lot. Definitely 50% memorization is required and 50% your problem solving techniques, maybe practice, whatever the RTDs, data frames, whichever. So her hobby is learning the new things and eager to learn new concept. Pay attention to class and learns the idea behind solving the problem. So A is not at all paying attention in the training and learning. B, of course, training is good, guys. Is good in training, but not paying attention in terms of learning. But C, attentive in the session. At the same time, learning also happens. The clear scenario, okay, which is really helping us to understand the reality behind the process of learning. Now, if that is the case, guys, obviously the story not ends here. Okay, there is a analogy here. So now what we're doing is just we are making use of out of the scenario. Just I need to pick up some summarization, some consolidation. That consolidation we are doing. Now we know about all these three members. Now we are applying some thought process on that. Now you see the professor first delivers lectures and teaches the students about the problems and how to solve them. Of course, he has given some examples and solutions also. At the end of the day, the professor simply takes a quiz based on what he taught in the class. Whatever the quiz. Okay, just based on strictly on the post quiz. Okay, after completion of the session, generally some professors and some faculty runs the quiz, which is purely from the discussion in the class. That is one way of assessing, of course. The obstacle comes in the semester test. This is the point, guys. Semester set test that the school lays down. This is where new questions comes up because this professor is internal, whereas university, some external professor may give the question paper. Though the syllabus is same, but the examples and the way he delivers the lecture is completely different with the internal and external. The expectation is also different, no? As a consultation kind of thing. So only these three guys are having the experience of their internal test with the different levels of understanding. In internals, this A is not going to perform well. B should perform well, and this is mixed. C guy, of course, she also performs, but somehow she's putting some attention somewhere, some other problem solving also. So here the conclusion, guys, the students have not seen these questions before and certainly have not solved them in the classroom. And they are not at all solved this particular external question paper in the quiz or something because altogether external paper is a different setup and all. Now, let me come to the analogy, guys. Okay, so just we are enjoying the understanding of this particular topic because always that's what I'm saying. You are in your presentation also, you need not give any rocket science or something jargons, technical jargons, not like that, guys. In a simplest way, this is a form of storytelling. Why I have selected this topic and is towards to our this overfit and as well as underfit. We have taken some scenario and we are trying to explain these things in a most simplest possible way. Now, the scenario here is internal and as well as the external exam. Now we'll see the thought process of all these members. Student A, who was distracted in his own world, his or her, simply guessed the answers and got approximately 50% marks in the test. On the other hand, the student who memorized each and every question taught in the classroom was able to answer almost all every questions by memory and therefore obtaining 98% of the marks in the class test, friends. In the class test, observe that 50% in the training, 98% in the training because of memorization, and 92%, not bad, but still not competent with the second guy. Because second guy is almost all preparing whatever the professor is saying and he is not preparing new things because professor obviously conduct the exams. Okay, academic professors I'm talking. So they conduct exam on their only a few professors Just they give the, they test the students on the real matters. Okay. And coming to the third member, of course, actually solved all the questions using the problem solving approach she learned in the classroom, because almost every questions he has solved, guys. The second guy, because he is very particular about the teaching and all these whatever the concepts he has trained. And new questions, actually, if you are referencing the third point, if you are making use of the monthly test or external test, whatever we are having other than our internal, so now the context got changed, guys, really. Let's also look at what happens during the monthly test when students have to face new unknown questions which are not taught in the class by the teacher. So just by guessing, as usual, in the testing, I can say 47% by A and 69% by B, 89% by C. That is what, friends, the important point is in our life also. Maybe if you are getting any less kind of the appreciations in the teamwork, and if you are not recognized, no matter, no problem. That is all a training kind of thing. But testing is in a real situation where there is a challenge arise, where even the people who judge you, the people who are on top of you, even they are also not aware of what what is the challenge. Then these kind of the candidates raise on top, guys. Though internally, though in the teams, they may not recognized or appreciated. Don't worry, because in the training, you may not compete with the second category people. Of course, first category is out of race actually. Maybe we are, because she is not at all paying attention for the training. On the same grounds, training and testing, she quoted 50, 47 according to her capabilities. But whereas if you are making the convention of the second category of the candidate, he's good in internal test, but whereas in the university or external kind of the test, definitely he is not competent, because in the earlier case it is 98%, guys, but now suddenly it degraded to 69 only, because he is very particular in the known questions and he is very good at solving the known questions. But suddenly, if you are giving the unknown things, then the test phase is gradually decreased. Whereas in the third category, of course, 92 in the training and nearby that 89% we got. Now, this analogy, guys, this analogy is perfectly suitable to our okay, so this analogy is perfectly suitable for our understanding in terms of model specification. I'm giving the summary. Okay, just whatever we have discussed in a simplest palette. In case of student A, things did not change much and still randomly answers questions 50% nearby. Okay, both training and testing, not a differentiation. And whereas if you are considering the second case, the student B dropped significantly, because in the training, the student could able to grasp everything because already is known aspects and all. Whereas in the testing, as is monthly test contained questions which he has never seen before. Okay, therefore automatically the performance went down significantly. But the third category member, guys. So in this case, the student C, of course, score remained more or less than the same. This is because the focus or learning the problem, solving the approach, and therefore was able to apply the concepts, okay, to solve the unknown questions. One life principle is there, guys. Uh, Whatever the situations, okay, arised in our life, you have to devise your future, guys. I mean, definitely future is not in our hands, but present is in our hands. Na? Present is in our hands. So learn from the experience and don't repeat the same mistakes. Do the new mistakes. Of course, we generally do that. but don't repeat the old mistakes. And there is a proverb like if you are repeating old mistakes, it is a decision, it's not a mistake. Yourself, you are committed to do the mistake, then nobody can save that. Category A. Category B, uh, he is very particular about the current situation and previous situation, and he never repeat that. Okay, just from that mistakes only he learn, and if any new mistake is there, he miserably fails because he don't know how to handle that. But the third member, okay, taking the situations, understanding the context, and planning the present so that he can reduce the number of mistakes in future. Though if any problem is there, he can proudly face those kind of the situations. So not like, if you are representing this kind of the things, in what way this topic is relevant to our overfit and as well as the underfitting kind of the conditions. Simply, if you observe this point, guys, actually, whatever we have discussed in the terminology of machine learning, how does this relate to underfit and as well as the overfitting in the machine learning? Not interested in learning, memorizing the lesson, conceptual learning. In the class test, 50%, real test 47, 98 and 69, 92 and 89. Okay, the similarities you can easily observe, guys. So don't go by temporary results. Okay, so whenever there is a requirement for what kind of the data, so whatever the orientation I'm having, in all those kind of the considerations, maybe in training or testing, in whatever the mode you are getting the data, so your data must be ready to your model must be ready to face training and test data. The classwork and class test resemble the training data here, and the prediction over the training data itself respectively. So just it is giving the predictions. On the other hand, the semester test represent the test set from our data, which we keep aside before we train our model, or unseen data in the real world machine learning project. So your data set, training, which is nothing but your classwork, testing, which is your university exam or external exam. That this analogy from the beginning we are making, but as a type of understanding to everybody. Okay, just I am consolidating the things again. Now, if I am asking you guys, so just by now also some people might be thinking, however, I got 98 percentage in my testing. Why I am giving the vote for the C member? Now you can see the point, guys, here. This is underfit or which is nothing but the biased learning. It is not at all learning, to be frank. And most basic way is a trial and error kind of thing, friends. Anybody can do that. Even if I'm giving any MCQ or if I'm giving anything, the person who is not at all attending my sessions and not at all gone through my videos or recordings, still he can answer in a random fashion. 50%, however, he can get now with his experience. And second member, of course, regular to the sessions, attentive, and definitely is a overfit kind of the thing, which is a memorizing aspect. Any new data comes in between, my model is really struggling to understand the patterns in the new data. This is what real learning, guys. Real learning. So considering the training and as well as the testing, though it is altogether a real data, because above and beyond the conceptual understanding is there, this is the best fit. Okay, so the memorization, friends, here important point is your algorithm should not by heart. The algorithm should not by heart. Whereas if you are making use of, okay, whatever the situation where any given model is performing too well on the training data, but the performance drops significantly over the test set is called the overfitting of the model. Okay, and similarly, if you are making use of non-parametric like decision trees, KNN, tree-based algorithms like random forest, are very near to the overfit, guys, because they are overly learning. Overly learning is similar to the by-hearting. These models can very complex relations which can result in overfitting. Okay, so but how to handle that, guys? Okay, so obviously, if you are making use of the convention, now I am putting this particular thing in a more suitable way. Let me see how you can interpret this particular graph. So this particular graph, so whenever the model complexities keep on increasing, and we are taking model complexity on x-axis and error as y-axis, and your model is too simple. If your model is too simple, it is underfit because your model is not at all ready to pick up the insights of the data. It is not capable of doing that, guys. It's not always the importance. Like every model is not having the capability of understanding everything. Suppose if I'm talking about the KNN, KNN is really not learning anything, guys. Just it is taking the data item and computing the appropriate distance, and then it is going to place that in a specific class. Whereas if your model is too complex, overly learning, and you are putting everything and all the training data is there. Okay, obviously, guys, both training error will be down with the more complex patterns. Training is good, guys. That's what 98% is, but your test error is maybe 68, something like that. So your model should be in between simple and complex. You should not always. That is one more thing, guys. And always don't think that complex models are going to give the best outcome. Never. Sometimes they give, but not always, guys. Don't think that, okay, every time I need to select the gradient boost, or every time I need to select the random forest so that I can cover every aspect. The problem is this one, especially if you select most complex algorithms, and that to the tree based models, all these things, they overly learn the data. And in the training phase, definitely they do really well, guys. But in the testing, they miserably fails because they are very good at by hurting. They are very good at understanding the patterns in the test, in the training, sorry. But in the testing altogether, if you give a data which is not at all known to the model, then they keep drop the appropriate aspects. Okay, but of course, we are not stopping here. Now, if the model performing poorly over the test and train test, then we'll call that as the underfitting of the model. It is case A, where she is not performing in class test and as well as the university test. And you are not great at, okay, your model is not good at both training and as well as the testing. That is what you call the underfit model. Example would be linear regression over non-linear data, because I'm having a complex data, but I'm not using a proper algorithm so as to handle that particular situation. Okay, so just if you consider the definition of this underfit, if the model is performed poorly over the test and as well as the train set, it is having real clarity, no matter whether that is a training data or test data. In both the cases, it is not performing well, maybe 50% or 40% like that. And example, really our data internally having some kind of the many patterns or parameters, but we are not able to capture our algorithm not able to capture that. That is what you call the underfit, guys, actually. Okay, and now if you are considering the example of the overfit kind of the condition. Okay, so just if I am making use of this overfitting, guys, so by this time you would have observed what exactly the overfitting is. The second example is related to the overfitting, actually. So the second example, he is very good at professor based, and any internal examination is there, then this guy is really doing well. But suddenly if I'm giving okay the external question paper, then there is a problem. So overfit can be generally termed as something when the ML model is extremely dependent on the training data. It is completely learning or by hearting, and it is very good in understanding of the training data. But the model is built from each data point view of the training data that is not able to learn and fails drastically when exposed to the new test data. This is the problem, guys, actually. Why many people are failing after training also, they are not extending their capabilities. They are not preparing and they are not learning really. Okay, the main problem is this point actually. Actually, your learning should start after the training completion. In the training, generally, I'll give all the possibilities, but in the testing phase, you need to explore more. That's what. So as to avoid the overfit, just I am giving these presentations so that you to create a new path, and I'm giving you some sort of the projects so that you can also explore and come back with whatever the learning along with your observations. Never overfit then in that particular case. And in it is mostly occurs in non-linear and non-parametric case. Just to observe here, non-linear in the sense your data is more complex, but you are applying only simple algorithms. Okay, occurs in non-linear, non-parametric. Okay, non-parametric in the sense guys, parametric algorithms or regression algorithms. Your regression algorithms are parametric, but whereas non-parametric in the sense like decision trees, random forest, all these are the non-parametric. Non-parametric refers to an assumption that the data doesn't have a normal distribution. Your data is randomly distributed. Many different kinds are there. It occurs mostly in complex algorithms like tree-based models and as well as the KNN. Okay, all these are the examples where there is a chance of overfitting. Now you directly ask this question. Okay, this we know, but how to handle that overfit? I'm coming to that point, guys, because if you are talking always about the problems, you are entry level. No matter how many years of experience you're having, you are entry level machine learning developer or data scientist. If you start talking about the solutions, then you are a pro, no doubt about that. Okay, now you see here, overfitting can overcome by cross validation technique like k-fold cross validation. We have seen that. Because why I have introduced that k-fold cross validation is that k-fold cross validation segregate the data between testing and as well as the training phases. So there is no chance of so displaying of the data in only test training phase. So because of this k-fold cross validation, the data will be distributed across the training and test phases. Boosting and bagging, keep on adding the appropriate feature selections or all these kind of thing, empowering the model and using linear models for the linear data. Suppose I'm having the simple data, better you go with the linear model. Grid search technique, friends, that also I have introduced. Like, in the algorithmic aspects like SVM, there we have seen some kernel and C value and all those other parameters. I'm in a I need to run again some simple code so as to come up with the best parameters. Rather, what I can do is with the help of the grid search technique, I can pick up the best parameters so as to maintain the convention. Pruning already we have seen, guys. Pruning is a process of avoiding the unnecessary paths, especially in the decision trees. There are certain aspects where the generation of the conditions and generation of the corresponding tree or childs, abnormally the tree is going to grow. But whereas at the moment you are not allowing the unnecessary path, then you have done with the avoidance of the overfitting. Now we have seen that regularization, penalization, lasso and ridge. Actually, these things belongs to the regression techniques. Apart from the linear regression, multiple regression, polynomial regression, we are having L1 and L2, lasso and ridge, along with the elastic net also. But these two are the most commonly used techniques so as to avoid your overfit conditions. Okay, so this is how you can see the solutions related to the overfit. Now, one more issue, though it is simple to handle, but the condition is underfit condition, guys. We know that, okay, if I'm using the just a simple algorithm to understand the more complex data, then I'll come to the category of the underfit models. So underfit model is neither good to the training data or not to the test data. This is worst condition, guys. because at least in the overfit we are happy up to the level of the training phase, and in the testing we really face the pain. But whereas if you are considering the underfit, it is not keeping us happy at the training phase and as well as the testing phase. So we need to handle this very carefully, guys. Inability of the model to understand or analyze the underlying trend or structure of the data, unable to derive critical information from the training data. It is not at all suitable for training and testing. This generally happens when there is not enough training data, or else even though training data is there, but you are opted for most or so simple algorithm, which is not at all ready to, not at all having the avenue of understanding the complex data. And here we are having high bias and low variance is said to be underfitting. High bias. Okay, biased kind of the model, whereas variance is not at all there. It is not interested to understand the different categories or different variance levels. Underfit might occur when we try to build linear models on non-linear data. Most complex data I'm having, but I'm choosing the option of going with the basic model. That is a major pitfall. And of course, we can easily handle that. But how do I, because finally I need to handle that convention. So definitely what is the solution? Because to handle that particular overfitting, we are having the read L1, L2 norms and as well as some sort of parameter tuning, all these things. And whereas if you are considering the underfit can be overcome by, already we have seen guys like feature selection, creating more features from the existing features, and polynomial regression is also one of the best so as to handle the underfit kind of the models. And if the accuracy of the ML model is 55% on training data and 50% on the test data, then it is clear case of the underfitting because the model is not performing well on the both train and test data. So underfit mostly occurs in simple algorithms like linear regression. So avoid those kind of the conventions. One simple aspect is try to select some sort of the best algorithms or the algorithms which are ready to perform the activity so that perform the analysis of identifying the patterns and all those kind of the considerations. So that's all for today's session, guys. So just we have almost all the things we have seen. Like if still you want any additional information, so definitely we'll schedule that, no problem. So maybe one doubt clearing session or maybe some additional availability session kind of thing so that we can learn more aspects. Okay, and thank you very much for your support all the way. So these 17 sessions, so all your presentations and all your submissions, I really enjoyed. So because that is the way how we learn the things. And then project. So just I'll take only 2 minutes, guys. Project already you have formed the batches. And we are having reviews also, review calls. Maybe just I'll be asking Deepika to schedule the review calls. So just the corresponding batches. You need not all the batches need not come. Okay, maybe for 4 batches I can conduct at one day, and another batch I'll conduct some other day. Maybe starting from today. Okay, so just to leave this particular week and we'll conduct on 17th. Okay, as a kind of review of the project, and final review we can give either 24th or 31st. That is your wish. Just 17th, basically I want to see what we are doing. So 17th, I'll ask Deepika to share the invite for the review of the project, and then I'll block straight away, ask to block your calendars. And if anybody absent means maybe in the corresponding timing, just you can ask me so that mutual just will block the calendars and we'll complete the review. And once that is over, we can go with the final review. Okay, that is one more important point. Okay, so that's all, guys. Thank you very much, and all the best. And it's not over. So maybe if you're having any doubts or any support from me or any additional information you require, any session, so definitely come to me, guys. So I'm always approachable. So just will try to build the good teams so that in a way empowering yourself and service to the company and all, right? Thank you. That's all. Yeah. Any doubts? I'll be staying here 1 minute to 2 minutes. And if you're having any doubts, just ask me. Otherwise, we can wind up.
Thank you, sir. Thanks for your all your support.
Okay. Thank you, Pawan. Yeah. But your time and date stamp, that time stamp, really, the presentation is nice to hear. Yeah. Okay. Thank you. Thank you very much. See you back. Okay. Bye.
Thank you, sir.